Do you actually know what's your home's power usage? It's been 1 year since Home Assistant has received the Energy tab. But do you know, after 1 year of Energy tab in Home Assistant, how much power does actually each floor, room, entity type or device use? Today we will be looking at how you can track the power usage of devices that do not have internal power metering. We'll start in a couple of seconds. Energy monitoring that has been added to Home Assistant last year in August, so exactly 1 year ago, has really improved how we can track the energy consumption of our home. But what if you want to track the individual power usage of each specific device? There are two ways on how you can do that. You can go for devices that themselves track the power metering, such as, for example, Shelly Plug S. Or you can use PowerCalc. What PowerCalc does is it creates additional energy usage and power usage sensors for each of the devices or entities inside your Home Assistant. So let me first make a little bit of warning here. If you yourself have 100 LEDs from Philips, IKEA or similar in your home and you install PowerCalc, default installation, it will create 2 times the same amount of devices that you already have. So for 100 devices, you will get 200 more sensors. Each of the lights will receive one energy and one power sensor. If you're not interested into so much new sensors, then this integration is not for you. This is my main setup. And what I did for the PowerCalc integration is I've added or itself added all the lights I already had in my system because it knows those lights. I have standard IKEA lights. PowerCalc has a database of known lights, both the manufacturers and the models themselves, and it then searches through that database and matches your lights that you have with the information from the database. If it matches it, then it can give you a lot more information about the power usage than just pure power metering that you would create, for example, for your own. How I tackled power metering for the lights before. For example, I had 7-watt LED bulb, IKEA bulb, and then I created a template sensor that would register when the bulb is on, and when the bulb was on, it would register 7-watt usage. Out of that, I could create kilowatt hours of how much power or how much energy that light bulb did use up in a specific amount of time. But that's not correct 100%, because there is a difference if your light is at 100% or if it's at 25%. And there is a difference also in power usage if you are using warm light or cold light. So to overcome that, PowerCalc in itself has a database that is populated by the users, because yes, you can create entry for the light bulbs that do not already exist in the system, and that everybody else can use the information for that specific bulb. For example, Elgato lights, those 2 lights here, didn't exist in PowerCalc before. What I did, I installed the Docker container, I took measurements. The measurements themselves took 3.5 hours because it was changing. I don't know what was the gradient, I think 1 or 5% between each change of the brightness and also between the cold white and the warm light. Then it created a database or file that contains all the information about Elgato Keylight Air lights, that knows how much power each individual bulb or light is using when it's in a specific state. Okay, too much information, I know. So let's look at what the PowerCalc creates. As I mentioned previously, I had IKEA bulbs. In my dining room, I have 2 IKEA light bulbs. One is called left, the other one is called right. If we type here left, we see that we have light left. It's currently in the state off. But we should also see here sensor left energy, and this is the information, kilowatt hours, for that specific light. We also have additional sensor called left power. This one is measuring current power consumption. If you can see here, it says that it is currently using 0.4 or 0.40 watts. And that's correct, because smart LEDs in the standby also consume some power. If I would turn the light bulb on, the power consumption of the light has gone up. Let's play a bit with the brightness. At around 50%, the power consumption is 2.42 watts. Okay, but if you already have 100 light bulbs, do you really want to see and track all of those devices or all of those entities or lights inside your Energy tab? Actually, no. You can group the lights, and PowerCalc is really great, but there is a lot of handwork there. You can create group of lights. For example, I created the lower floor and upper floor. And I've added inside the lower floor each of the rooms that is on the lower floor. And then inside of each of those rooms, I'd added specific lights. In my sensors folder, that means inside your sensors.yaml file or inside configuration.yaml file, you would create sensors for each of those specific lights. My PowerCalc group is called downstairs lights. Inside it has entities. Entities can be individual entities, or further you can create groups. So inside group downstairs lights, I also have group balcony lights. And inside balcony lights, I have specified the entity ID light.balconylight. Then we have group corridor lights, kitchen lights, which has bunch of lights, dining room lights, and living room lights. What this has created? This has created one big group that contains all the rooms with all the lights that are downstairs. The same thing goes for the upstairs lights. You can, as I mentioned, just add direct lights inside that upstairs lights, or you can nest further rooms. For me, it was bedroom, Luca room, Zita room, ledge lights, and loft lights. So what do you have to do to install PowerCalc, and what is the minimum configuration? For that, let's go to my recording setup. No, we will not be looking at the NS Panel Pro. Instead, we will go to HACS, Integrations, press on plus and type here PowerCalc. Press on it, click on Download. The version at the time of the recording is version 0.24.8 and click on Download. This is, I would say, the first of the two steps that are minimum for all the installations. As with any HACS integration, you have to go to Developer Tools, check Configuration, and restart your Home Assistant. Home Assistant is still starting up, but we can take that time and look at the documentation. We already did the HACS installation part, and the next step, or post-installation steps, is to add PowerCalc to our configuration YAML file. Starting with the version 0.12 of PowerCalc, it can automatically discover entities in your Home Assistant instance which are supported, and for those entities it can create energy and power sensors. Some with whom I've talked said they hate the idea of system being overwhelmed with all those entities. But there is one thing that you can do if you do not want the system to automatically create all those entities, is to disable auto-discovery. PowerCalc now has the UI editor that allows you to create virtual sensors, but not everything can be configured through the UI. Some of the things still have to be configured through the YAML. This section here is part of the global configuration. So if you want to disable that auto-discovery, all you have to do is enable auto-discovery and set it to false. At the end of my configuration YAML file, I will add hash and PowerCalc, so I know that this is the start of my PowerCalc configuration. Next, we need to add one more line, power, and this is all we need to add to finish configuration of PowerCalc. As I mentioned a couple of seconds ago, if you want to disable auto-discovery, you just have to add one additional line and add enable auto-discovery column false. By default, this is true. I will disable it. That way, for all of the lights that exist in my Home Assistant setup that match the contents of its database, we will have new entities or new sensors created, power and energy sensor. Of course, you have other global configuration options such as force update frequency, create energy sensors, which is by default true. You can play with the naming of power sensor, friendly naming, category, energy sensor naming, friendly naming, create utility meters, etc. But I leave that for you to play with when you install PowerCalc. Let's restart our Home Assistant for the second time. Now that our Home Assistant has restarted for the second time, let's look at the lights I had previously and newly created entities. We have light sync that is currently in the state on. We have energy that is still unknown because it is calculating what is the current energy use or what is the energy use for it. And we have information about the current power use. It's currently using 8.76 watts. After some time, you will see a sensor energy populated because some time needs to pass for it to calculate what energy was used by that specific light. We have light oven that's on, energy is also unknown, and it's also using 8.76. If I would play with it, we can see that currently it has used 0.0006 kilowatts, and this both here the energy usage and the power usage is changing depending on what is the state of the light. Or more graphically, if the light itself is off, we see that currently it is using 0.4 watts, and overall consumption of that specific light currently so far, because this is a new installation, is 0.0006 kilowatt hours. If I would turn it on, it would go to 8.76, and this here will slowly start to rise. PowerCalc uses for calculation of the power usage a couple of methods. If it's using the internal lookup table, it's using this LUT mode. Supported domain for this is light. If the light itself exists in the database, it will try to match it. If it finds it, then you will have all the data available to properly calculate and track the power usage. Linear mode is used for lights and fans. You specify the minimum power, the maximum power. And for example, for the fan, if it is at 100%, it would then be using 8 watts, and if it's at 50%, it would be somewhere around 4 watts. Fixed mode, on the other hand, can be used for a lot of other things, such as lights, fans, humidifiers, switches, binary sensors, device trackers, remotes, media players, input booleans, numbers, selects, other sensors, climate, vacuum, and water heaters. For heaters, that would, for example, mean that if it is in the on state, it would use, 2 kilowatts of power. The documentation for the PowerCalc is really great. So if you have a specific case, I really suggest that you go and look at the documentation. Power per state is great, for example, for the media players, which I did mention previously. For example, if Sonos is idle, it is only using 1.5 watts. If it's paused, it's using 2.25, and if it is playing with 8.3 watts of power. But this can be further improved. For example, once again, if we look at a Sonos, state's power can depend on the content ID. If it's Spotify, it's using 5. If it's YouTube, it's using 10. Previously, I also mentioned WLED. I track my 6 or 7 LED strips that are powered by WLED also with PowerCalc. For each of those devices, unfortunately, I did have to add them by hand, but the configuration itself is no issue. You just create a sensor, platform is PowerCalc, entity ID is the light entity ID of that specific WLED, and then you specify WLED and the voltage. For most of my WLEDs, the voltage was 5. But I also had one that is using 24 volts, so because of that I had to change this from 5 to 24. And if you're interested in multiple entities or groups, I suggest that you look at advanced features of PowerCalc. As I've shown you previously, in my setup, I'm using nested groups, by floors and then by rooms. Last thing is that you can use the utility meter, if you want. In my setup, I haven't enabled utility meters. Actually, I do have it enabled, but for my Shelly EM that is tracking the overall power consumption or power usage in my apartment. I track it by day, month, quarter, and year. If you want to track that for each of the specific devices or entities, you can enable it, but don't forget that it will create additional sensors and it can be overwhelming for you to manage or for your Home Assistant. I did mention creating virtual sensors. You can do it through the YAML files, but also you can add integration here, type PowerCalc, and create something, for example, virtual power. For source entity, let's look for switch. For example, this elevator detect. We can use fixed calculation strategy. Standby power can be, for example, 0.2, and that is how you add virtual devices or virtual sensors. And when you finish configuring everything, you should have something like this. As I said, I've created groups of lights depending on a room, but you do not have to go to specific rooms. You can create floors or some other, to you, meaningful way to track the energy or to know what is behind each of the sensors. I think that PowerCalc is really powerful way to further track the power usage in your home, even if your devices themselves do not have capability to do power metering. If you want to know where your power is going and what devices or rooms or categories are the ones that are using the most energy in your home, PowerCalc is definitely a way to go. And it's much cheaper than buying devices that are then used to track the power metering or power monitoring of specific device or whatever. Oh, by the way, do you know that on 8th of September it will be 3-year anniversary of my channel? Don't forget to subscribe and hit the bell button so you get notified because there will be 2 giveaways. I will be creating one giveaway for everybody who is a channel subscriber. And also there will be one specific giveaway for all the channel members. Because yes, they've been supporting me for a long time and I want to give something back to my YouTube channel members. But while we are on that subject, I really would like to thank each and every one of you who has become a YouTube channel member. Thank you all for all of your support. But also thanks to you who have watched, liked or subscribed to my channel. If you too want to support the channel, you can do so by clicking the join button down below. If you have any kind of a comment or a question, you can always leave the comment down in the comment section below. Or even better, go to the Discord server, the link to Discord server is down in the description of the video, and leave your comment then. And of course, if you did like this video, don't forget to give me a thumbs up. I'll be seeing you next time. Until then, bye bye and have fun.